All right, our final task here, number 8, parabola. All right, and so this parabola task is basically doing the same thing as the number 3, the intercepts kind of task, where we want to, first of all, we want to plot the graph of a parabola. So graph of a parabola in general looks like this. Y is equal to, and then it's an ax squared plus bx plus c kind of situation, and you can use whatever numbers you want to. I'm going to do a third. Why is that a line? The reason why it's a line is because y equals a third is a line. You need to throw an x squared on it. Now it's a parabola. I'm going to make this a little bit more complicated though. Minus 6x. Oh, I'm really off the screen. Doesn't really matter. And then maybe plus 5. Okay, that should do it. I made it minus 5. Okay. So what's this asking me to do? Find the vertex, coordinates of the vertex of the parabola, and import the point into the expression list below. Now you can see that I don't even, I can hardly even see the parabola. It just looks like one sliver of it. But, Desmos, pretty interactive, really easy for you to just zoom in and zoom out. If you're on one of those Chromebooks that's touchscreen enabled, you can just do exactly what I'm doing here by just pinch zooming. Otherwise, you would do it on your trackpad, or you can use your plus and your minus buttons that are over here. And if you ever want to go back to the default view, you just hit the little home button. That's not very useful. Okay, so let's get it so that I can see a complete graph here. Now, there is an algebraic way for you to find the coordinates of the midpoint, and it has to do with part of basically the quadratic formula. Okay, but again, we're trying to save ourselves some time, and one of the things that Desmos does for you is that it automatically highlights some key points on a graph. So if I just highlight my graph by just clicking on the graph, look, the vertex is already highlighted. So are the two x-intercepts, and so is the y-intercept. Those are points that are already highlighted as they're a little grayed out a little bit, just so that you can go, maybe that's a point that I want. So if I just click on it, now I have the exact coordinates of the vertex, the turning point of that parabola. And just like I did before, I don't have to type it. I can import it directly into the expression list by hitting the little icon to the right of the ordered pair. The thing that looks like an arrow pointing to a rectangle, it just is the little button that enables me to pull that number directly into the expression list. All right, so I'm going to turn this label on. And now let me just kind of click and drag this thing right up here where it's supposed to go and delete out the extra little box there. All right, and then who knows, maybe what I want to do is just label this thing with the vert. How about vertex? Yeah, there's the vertex of my parabola. Now, this wasn't asking for this, but I'm going to take it a step further just to make your algebra teacher very happy. Do you remember that there is a vertical line that goes through the vertex that splits this thing down the middle? It's called the axis of symmetry. Axis of symmetry, vertical line, goes through the x-coordinate of the vertex. The x-coordinate of my vertex is 9. Watch this business. I'm going to do x is equal to 9. Bam, I've got myself a line that goes through it, and who knows, maybe I want to change this to a dash line or something like that. All right, and let's hit done there. Now, what this also does is it assumes that you want to vary that, so it throws a slider in there for you. I'm just not going to touch the slider because if I do, it's going to get off of my actual vertex there. All right, now, what else did it want us to do? Well, it wanted us to find the x-intercept. So these are among the most important points for any parabola. This is the vertex, it always marks the minimum or maximum. If your quadratic equation is supposed to be modeling something mathematically, then that vertex will show you where the maximum or the minimum, in this case, this one's a minimum, of that quantity is. However, if we're trying to solve the thing, solving the thing means find the solutions, and the solutions usually are associated with the x-intercepts. And the x-intercepts I can just find by, just like we do with line, if I just click on my graph, it automatically kind of highlights where they are, a little bit grayed out, and if I just click the little dot, I can pull it really quickly into the expression list without having to keep track of all these weird decimal places. And I'll do the same thing with the other one here and then pull this into the expression list. And I want this thing to be with the other stuff, so I'm just going to kind of click and drag these guys up to where they're supposed to go. And there you go. Get rid of those guys. And who knows, maybe I put these little labels up here, and maybe I want those numbers to come up because these numbers themselves are the solutions, the zeros, the x-intercepts of this quadratic function that we've got going on. And I'm going to highlight this one more time, just in case you didn't watch a previous video. What I want you to notice here is if I go up to box number 57 and I delete out the y equals. If I delete out the y equals, boop, boop, notice that it still graphs my parabola. However, I would like for you to get into the habit of making sure that if it is a function, that you type it in as a function. A y equals. You have both an x at pi, both an x variable and a y variable. And it's really, really underscoring the importance of understanding that that's what a function does, is it takes x numbers and pairs them up with y numbers, the domain versus the range. And even more useful than that is if instead of calling this thing y, I call it some other letter, like a function. I can call it f of x, I can call it g of x. You remember using those in algebra, and I'll show you the usefulness of that kind of thing. So I'm going to call my parabola here, my quadratic equation. No, let's use g of x. So I think I used f of x someplace else. So g of x is equal to, and then there we go. So it still graphs the parabola just fine, but here's the benefit of this. Now this thing is called g. So if I wanted to do anything further in the expression list with that function, if I wanted to evaluate it, for example, at any particular point, I can do that pretty easily. And as a matter of fact, what I could do is I could set up a slider and I could just put the value of that slider right into the function, which is really cool. So for example, I'm going to pick a letter that I haven't used yet. Let's say that I choose an H. And let's make this H is just equal to 1, right? And then if I hit enter, I've got myself a little slider here. Now I'm going to evaluate the G function specifically at this little slider here. So I'm going to do a G, do some parentheses, and then my, what the heck was it? H, yeah, a little H. Throw a little H in there, and then maybe hit enter on this. And notice that it evaluated it for me. It took 1, plugged it into the g of x function, which is on 57, and gave me my answer. Not only that, I can interact with this, and it will tell me what each one of these little values is when I move my slider left or right. All right, so all of this is kind of extension of some of the things that you could have done here on this final parabolic task on the beginner leveling up Desmos. So expect more to come in the next 2 weeks as we level up even further with Desmos.